So consider an Atwood machine. Block A is 25 kilogram and block B is 12 kilogram. And we are assuming that there is no friction. So we want to draw a free body diagram for each of the blocks, block A and block B. And we want to find the upward acceleration of block B. And we also want to find tension in the rope. So start with the free body diagram. So draw free body diagram for A. And free body diagram for B. So for A, obviously it has weight, gravity force is pulling it down. So draw this downward arrow. And let's call that WA. There is no horizontal force, but the block is attached to a string, and whenever an object is attached to a rope or a string, there is a tension, tension that goes away from the object. So tension is always pointing away from the object. So here the tension is pointing up. That's T. And then for block B, it also has weight. So that's for block B. And this weight would be less than weight A because block A is heavier than block B. So I'm drawing a smaller arrow. And then this one also has tension because it's connected to the rope. And the tension is always away from the object. It should be a straight line, but it doesn't look a straight line. Now, these two ropes are connected through the pulley, so that means the tension must be same. So this tension and this tension, you can, if you want, you can write this TA and TB, but they would be same because they are connected. They are pulling each other, so tension A is equal to tension B, and you can just call that T. So that's all the forces we have, and then we also need to decide the acceleration. It says the block B is accelerating upward, so this is accelerating upward, and if it accelerates upward, then object A must accelerate downward, because both cannot accelerate up. So one goes up, other goes down. If B goes up, A must go down. So then acceleration for A would be down. No, sorry, is it right? No, I take it, is it right? Yeah, so that's right. So block A is heavier, so it should go down. And block B is lighter, so it goes up. So that's right. Oh, where did it go? Yeah. Yeah, that's right. So that's, thanks for pointing that out. It should be WB. What happened? So that should be WB. Okay. And magnitude wise, these accelerations are same because they are connected. So if A is accelerating up at some value, then B should be if the B is accelerating up at some value, then A should be accelerating at the same rate down. Okay, they should have same values magnitude wise because they are connected. So next thing is we want to define the coordinates, and I recommended last time,,, we define the coordinate along, in such a way that the positive would be along the the direction of acceleration. Okay. So here the acceleration is down, so we will define the coordinate such that the positive y is down, negative y is up. And here acceleration is up, so we'll define the coordinate with positive y up and negative y down. So next is, now we will write the Newton's law for block A and block B. So for block A, Newton's law is sum of forces along y direction is mass times acceleration. Okay, so what forces we have for A? We have weight, it's along the positive y direction, so we need to use positive sign for that. And then TA, or you can just call it T. T is up, and for block A we are considering up to be negative, so negative T is equal to m acceleration is down, and down is positive, so let's write A. So that's for block A. For block B, sum of forces along y direction is MA again. Here you need to be very careful with the notation. So here we are talking about mass A or block A, so you need to write here MA, okay, M sub A, because this mass and this mass are different because they have different masses. So this is the mass of B. So for B we have T, tension in upward direction, which is positive, okay, tension is positive, and weight is down. For B, down is negative, and that is equal to mb times acceleration. So the question is asking to find this acceleration. So we need to solve these two equations to find the acceleration. So this, call that equation 1, call that equation 2. So when you have these kinds of equations, think about what variables are given and which variables are unknown. So question doesn't say anything about tension, so we don't know what the tension is, so we need to eliminate somehow this tension. So to eliminate tension, you can write this in terms of tension and then substitute that in the second equation. Okay, what I mean is you can write this as, or you can write this one as T is equal to MBA plus WB. Okay, just I'm taking this WB to the right, and then substitute that T in this equation. Okay, and then the tension will be eliminated. So then we get WA minus T is this thing, MBA plus WB is equal to MAA. Okay, and weight by definition is mass times acceleration due to gravity, so we can write WA as mass of, so let's write small case, so MAG minus MBA. This negative and positive, multiplying negative and positive becomes negative. Weight of WB is MB times G and MAA. Okay, so we want to find A. That means we want to write all the terms with A on one side and everything else on other side. So this one has A, this one has A, so put the terms with A on this side, and then everything else on one other side. Okay, so we have MA G minus MB G, MA A. When you take this to the left, to the right, negative becomes positive. MBA. So what is common in these two terms is G. So you can put G outside the parentheses. And then here, what is common in between the two terms is A. So put A outside the parentheses. And then divide both sides by MA plus MB. You can cancel MA and MB, MA plus MB on numerator and denominator. So that would give us A is equal to MA minus MB over MA plus MB times G. Okay? And then you can substitute the values to find acceleration. Mass of A is 25 kilogram. Mass of B is 12 kilogram over mass of A 25, mass of B 12, and the value of G is 9.8 meters per second squared. Okay. So when you do that calculation, you get 3.4 meters per second squared. Okay. So that's part B. Part C, what is the tension in the rope? So we want to find tension. So you can substitute this acceleration in one of the equations to find the tension. So go back to the equation here. So either choose 1 or 2. So use, let's say, 2. So we have T is equal to MBA plus W is MBG. So T is equal to M and M are common, so you can pull it out of the parentheses. So A plus G. M B is 12. A is 9.8 meters per second squared. G is, sorry, A is 3.4 meters per second squared, and G is 9.8 meters per second squared. And when you do the calculation, you get 158.4. Tension is a force, so its unit should be Newton. Okay. So that's number 5. So before we start number 6, let's talk a little bit about the cases where we have more than one object, when the two objects interact with each other. So we know from Newton's third law, it's not doing anything. What happened? Okay. So when you have two objects and you apply force on one of the objects, so the two objects are touching each other. Okay, so let's say you have A and B. You push the object on the right, and then in turn, this B will also push on A, and then A will also push back on B. Okay, So they will apply action and reaction forces. So B exerts action force on A, and A exerts reaction force on B. Okay. So that is what Newton's third law is. So Newton's third law is, for every action, there are equal and opposite reaction. If you push a wall or something, then the wall also will push you back, okay, with the reaction force. So when you put a book or something on a table, so that's a table, the weight of the book will push the table down, and in turn the table will also push the book up. Okay, so these two are action and reaction pairs. You can call this one action, and this one is reaction. So we will talk a little bit more about how the objects interact with each other when they exert force on each other. Okay, so let's look at this. Scenario. So how do we solve problems that involve interaction between two objects that are in contact? So to solve the problem, we first need to write the free body diagram for the individual objects. So you start with one of the objects. Let's say choose object A, okay, and then identify all the forces that are being exerted on A. So you write free body diagram. So you have force applied on A by hand, call that FH. And then this A will exert some force on B, and in turn B also exerts force on A. So there is a reaction force of B on A. So let's call that force of B on A. So this is for object A. So when you consider object A, think about only those forces that are being acted on A. Okay? Don't think about the force A is exerting on B. This A is also exerting force on B, but we don't care about that. Okay? This A also exerts force on the hand. We don't care about that. All we care is the forces that are being exerted on A. Okay? So these are the two forces that are being exerted on A. So you will write free body diagram individually for A, and then also write free body diagram for B. So on B, what forces are acting? There's only one force acting on B, which is force of A on B. Force of A on B. There's nothing else. Okay, this is frictionless surface. So A pushes B, and there is no other force. And I'm talking here only about the horizontal force. Okay, you also have vertical force, but let's not worry about that for a second. So horizontally, A has two forces, and B has one force. And if you consider hand, so this is hand. How many forces are acting on the hand? Yes, so there's only one force, which is the reaction force of A. So force of A on hand. Okay, so you need to write the individual free body diagrams. That's the first step. And then you need to identify action and reaction pairs. Which ones are action and reaction pairs? So it's pretty easy to identify action and reaction pairs. So if you have force like this, so force of A on B, then you flip the letters here. That would be the reaction force. Okay, so F, you flip that, B on A would be the reaction force of that. And then according to Newton's third law, these forces are equal. Okay, in this case, you see this force and this force, B on A and A on B are action and reaction pairs, and they must be equal. Okay? So you need to identify that. That's the second step. And third step is, since the objects are touching each other, all this system means hand, A and B, they all have the same or common acceleration. Okay? They are moving all at once, so they have same acceleration. So that's the third step. And the fourth step would be, you get bunch of equations, and you'll solve the equation. Okay, I'll show you how to do that in the next part. So let's see how we apply this in a problem. So this is, we'll come back to number 6 later, but let's look at a problem from a new worksheet. I'll come back to number 6 after doing the new problem. So this is the problem from, I don't know why it's, so here's the problem. This problem is also, you can find this on worksheet 9. Okay. So here, this hand is pushing the block A to the right, and because A and B are also touching each other, so A will also push B, and then in turn B will also push on A because of the reaction force. So the question is, what force does block A exert on block B? So how you denote that, the force of block A on B? So to denote that, you write the object that is exerting force as the first letter, force of A, and then write on, and then the force on which you are the object on which you are applying the force would be here, okay, on the second part. So force of A on B, this is what we want to find. So, like I said before, so we need to start with free body diagram for individual blocks. So let me do this on different page. Let me reopen that. So let's copy the figure. Okay, so here we want to find force of A on B. Okay, so start with free body diagram for block A. So there is force of hand on A, and there is also reaction force of B on A, force of B on A, and all we care here is the forces that are being exerted on A, okay, not the other forces. And for B, there is only one force, that is the force exerted by A on B. And if you want to draw free body diagram for hand, you will have force of block A, force of A on hand. Okay. So then you will write free body the Newton's second law for each of the objects. So for A, you can write F along x direction is m times acceleration of A, mass of A. Okay. So how many forces we have? We have two forces, and we are considering this to be positive and this to be negative. So F of hand on A minus F B on A is m A, and they have common acceleration, so I'll just write acceleration as A. Okay, so that's for that. And this equation won't give us this thing. This is what we want to find, because there's no this term in this equation, so we want to write equation for B also. So write the same kind of Newton's law for B. So the only force we have here is F A on B, that is equal to mass of B times its acceleration, same acceleration here and here because they are touching each other. Okay. So, and from Newton's third law we know that F on B, F of A on B is equal to F of B on A, okay, magnitude wise. Magnitude wise they have same magnitude, action and reaction forces. So that means this would be also equal to F B on A. Okay. So MBA. Now we can substitute this thing here, because just a second. No, I think that won't give us this thing. So this is what we want to find. So we want to retain that. Okay. So how do we do that? Let me go back. So we need to think about how to get this one. So this is what we want. Okay. And we don't have acceleration, so we want to somehow get rid of acceleration. So the question doesn't give us acceleration. Let's go back to the question. Yeah, the question doesn't have acceleration. So we need to eliminate the terms that are not given. So think about how to eliminate this A and this A. How should we do that? So we have F A on B, which is what we want to find, MB. Replace this A by this. So we can write here, we can write A is equal to FH on A minus FB on A, okay, over MA. The reason I'm doing this is because I want to get rid of that. Okay. So now you substitute that here. So MB, A is FH on A minus FB on A over MA. Okay. And we don't have this, but we know that this is F A on B, okay, from Newton's law. So here you see F B on A is equal to F A on B. Okay, so these two things are same. So to solve that, same kind of idea, just a little bit different kind of math here. So let's simplify this by multiplying both sides by MA. Okay, MA. Cancel that. So we have here MA F A on B is equal to MB. So this is F H on A minus this is F A on B. Okay. All I'm doing is just distributing this M to each of these terms, and then this is basically that. Okay, I'm replacing this by that. And the reason I'm doing this is to get FA on this. I want to get this one. Okay, so MA FA on B. Take this one to the left. In other words, you can also say that you're adding MB FA plus FA on B, and same thing on the left. Okay, I'm adding this term on left and right, so you can cancel that and that. So here I have MB FH on A. So here we have this thing common. You can put it outside the parenthesis when you have something common between the terms. So F A on B is equal to MB F H on A. Okay. So F A on B, which is what we want, that is equal to MB over MB plus MA times that FH on A. Now let's look back to the question and see if we are given all these things. So let's see. So we are given MB and MA. Okay, so all these things are given, and then we are also given the force of hand on A, which is 3 Newton. So we have everything on the right. So with that we can find F of A on B. So MB, mass of B is 10. MB is 10. MA is 5, and force of hand on A is 3 Newton. Okay, so you need to do the math. So 10 over 15 times 3, 5, 2, 5, 3. So you get 2 Newton. It's all algebra, so if you know how to do the algebra, it's not that difficult, but sometimes if you mess up the algebra, that gives you the wrong answer. Okay? 2 Newton. So try that, redo that, okay, and then see if it doesn't make sense, then you can come back and ask me a question, but it's not that difficult one. It's only how to manipulate all these, the algebraic terms. Now let's go back to number 6 from worksheet 8. So visualize the problem. So there is a book A that sits on top of book B, which sits on a table. So we have a table and there is a book. B, and there is book A on top of B. So we want to draw a free body diagram for each of the object listed and put these side by side. Okay. So we want to write free body diagram for A, free body diagram for B, and also free body diagram for the table. So let's start with A. So A has mass, that means it must have weight. First thing is we draw weight, gravity force, and we only care about the force that is being acted on A. Okay, so that means we want weight of A. Tell me what else, which force is acting on A? Yes. So this weight pushes B down. So there is B, there is A. So this weight of A pushes B down, and in turn, Newton's third law, this B also pushes A up. Okay, so there is force of B on A. That's what we want to show here. So force of B on A. And then this is for A. For B, what forces we have? We have weight, because it has mass, so weight of B. And B is on the table, so the weight of B is pushing the table down, and in turn, the table is also pushing block B up. So there is normal force or reaction force of table on B. Okay. And this A is also pushing B down, because these two are touching. You see here, this A is touching B. That means this A is also pushing B down. So there is push force of A on B. Okay. So those are the three forces acting on B. And then table. Okay, so table also has weight. So that's weight of the table. And then the table is on the floor. That means the floor must be providing the normal force on the table. Okay, so the net normal force provided by the floor on the table is N. Call that N, normal force. Or you can also, if you don't want to write that, you can also write force of the floor on table. Or you can just write N, okay, whichever you want to write. And then block B is touching the table. That means block B is also exerting force on table. So this block B is trying to push it down. That means there is force of block B on A. So there is force of block B on A, table. Force of block B on table. Okay, so those are the forces on the table. Now we want to find the third law pair. So again, third law pair is pretty easy to find. If you have if you have force of B on A, then switch the order of these letters, then that would be the opposite force or reaction force. Okay, so if you have force of B on A, then its reaction force would be force of A on B. Okay, so here this force and this force are action and reaction pairs, And then here we see force of table on B and force of B on table. These are also reaction and action and reaction forces. So that's the answer to number B, part B. And then part C, what's the magnitude of each force on each of the free body diagrams? So we want to find all the forces that we labeled here. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8 forces. So we want to find all those 8 forces. So let's do that. So that's pretty straightforward. So start with this weight of A. Weight of A is mass of A times acceleration due to gravity. Mass of A is 4 kilogram. Acceleration due to gravity is 9.8. So multiply the two, you get 39.2 Newton. And then the second force is force of B on A. And how do you find that? It's pretty straightforward. So you see, if you draw the free body diagram here, I mean, if you write the Newton's law here, Newton's law would be F B on A minus WA would be 0, because there is no acceleration up or down. It's not accelerating up or down. So A is 0 here. Okay, so that means this would be equal to that. So this would be equal to WA, which is 39.2 Newton. Okay, because these are equal because because the object is at rest. Okay, at rest. Now C, we have force of A on B, which is the same as force of B on A, action and reaction. So that's 39.2 also. And then D, this one, WB. WB is MB, weight is mass times acceleration due to gravity. Mass of B is given, 14 kilogram. G is 9.8. So multiply that, you get 137.2. And E, force of table on block B. Is it book? Yeah, book B. Force of table on book B. So what's that? So here you can write Newton's law again for this block B. So sum of forces is M times A. That's the Newton's law. So we have F T on B, upward force, and we have F A on B, downward force, and then we have WB, downward force, and these should be equal to 0 because no acceleration up or down. So we want to find this. That would be F A on B plus WB. Okay, so F A on B, we already found that, 39.2, and WB, we already found that, 137.2. So you add those two, you get 176.4. Okay, so we have found 5 forces. Now we need to find 3 more. So let's find the next one. So the next one is WT, weight of the table. Weight is mass times mass of table times acceleration due to gravity, and mass of the table is 25 kilogram. Acceleration due to gravity is 9.8. So multiply that, you get 245 Newton. So we got that. Okay, we got all these forces. And then the next one is force of B on T. So get this one. Force of B on T. And this one is same as force of T on B, action and reaction. Okay, just switching the letters. And we already found this one. Okay, so we got this Ft on B, which is 176.4. So 176.4 Newton. And the last one is force of floor on table. Force of floor on table. You can write free body Newton's second law for that. So let me do that. So that's pretty straightforward. You don't even have to excuse me. You don't even have to like write the detailed equation. So this is not accelerating, so that means upward force must be equal to downward force. Okay, so this is upward force, that must be equal to the downward force. So downward force is F B on T plus WT. Okay. So now substitute the values. So B on T, we got that 176.4 Newton, and WT is 245 Newton. Okay, so add that, you get 421.4 Newton. Okay, so we got all the forces. Okay, so I think we have 2 more minutes. If you guys have any question, I can answer your questions. Otherwise, I think that would be all for today. And there will be a quiz available sometime this afternoon. I haven't uploaded that on Blackboard yet. So please do not forget to take the quiz by the end of the day.